Hello students, we will talk about general anesthetics. By definition, general anesthetics are the drugs which produce controlled, reversible depression of the functional activities of the central nervous system, and that produces loss of sensation and consciousness. If you see the general characteristic features that ideal general anesthetic should have, so you can say it should be inert, it should be potent and non-inflammable, it should be non-irritating to the mucous membrane. Secondly, it should produce rapid and smooth anesthesia. It should produce analgesia and muscle relaxation in addition to anesthesia. It should not produce severe hypertension. It should not produce nausea or vomiting. Also, it should be compatible with the adjuvant drugs which are used in anesthesia. It should be economical. It should be stable to heat, light, and alkalis. Now, if we see the classification of general anesthetics, they are divided into their according to the nature into volatile and non-volatile. So we have volatile, inhalation, general anesthetics, and the other one is non-volatile or they are intravenous. So in the volatile inhalation general anesthetics, we have two types, gases and liquids. So they are administered by inhalation. The examples of gaseous volatile general anesthetics are cyclopropane, ethyl chloride, nitrous oxide, and the liquids we have diethyl ether, chloroform, halothane, and trichloroethylene. Then in the non-volatile or the IV intravenous anesthetics, they are non-volatile at room temperature and they are administered by IV route. So we have two types again here. One is barbiturates and the other is non-barbiturates. The examples of the barbiturates, we have thiopentone sodium, methohexatal sodium. And in non-barbiturates, we have propanidine and propofol. We'll talk about general anesthetics. Let us first discuss cyclopropane. Cyclopropane is a cyclic aliphatic hydrocarbon. Properties: it is a colorless, flammable gas with a characteristic odor and pungent taste. It is supplied in the compressed form in the metal cylinders. Cyclopropane forms explosive mixture with air. The cylinders of cyclopropane are painted red. Uses: it is used as a general anesthetic. It produces rapid and smooth induction, good muscle relaxation, and it has a wide margin of safety. This is administered by inhalation. Second compound is ethyl chloride. Chemically, this is a chloro-derivative of ethane, and this is gas at normal conditions, and it is available in the compressed form. Now, this is prepared from ethyl alcohol by passing dry hydrogen chloride into it. Ethyl chloride is a volatile liquid having pleasant ethereal odor and burning taste, slightly soluble in water and also miscible with alcohol and ether. Uses: this is used as a general anesthetic which is administered by inhalation. Then we have nitrous oxide. This was first anesthetic that was first Joseph Priestley reported its preparation in 1772. It is prepared by heating ammonium nitrate at 200 degrees Celsius. Now, if you see the properties, it is available as odorless, tasteless, colorless gas. It is supplied in the blue colored metal cylinders and it is soluble in water, alcohol, and ether. So that is a method of preparation. NH4NO3 gives N2O plus H2O. Uses: in 1800 it was first recognized its anesthetic properties. It is used to induce anesthesia and followed by ether, halothane, or methoxyfluorine. It is also used for short dental procedures. Then we have diethyl ether compound. Diethyl ether was first compound to be used as anesthetic by American doctor. In 1846, James Simpson popularized the use of ether as anesthetic surgical operations. It is prepared in the laboratory and on the large scale by heating the mixture of ethyl alcohol in presence of on anhydrous calcium chloride. So you can write the reaction as CH3CH2OH plus H2SO4 will give CH3CH2OCH2CH, that is ethyl O ethyl plus H2SO4 plus H2O. Now if you see the properties, diethyl ether is a colorless, volatile, highly inflammable liquid having sweet burning taste and characteristic odor. The anesthetic ether should be stored in well-closed, light-resistant containers in a cool place. Stabilizers like sodium pyrogalate, hydroquinol or propyl galate are added to the anesthetic ether. It is a safe general anesthetic and it is inexpensive. Then the next important compound is halothane. This is 2-chloro-2-bromo-1,1,1-trifluoroethane. Halothane is a colorless, non-inflammable liquid having chloroform-like odor. It is non-irritant to the skin and mucous membrane. If you see the uses, it is one of the most widely used potent anesthetic agent. 2.5% is used. It is administered through N2O nitrous oxide air mixture. It has more rapid induction recovery compared to ether and methoxyfluorine. It is more potent than chloroform and ether. Some disadvantages are there. It reduces cardiac output and causes peripheral vasodilation, leading to hypertension or low blood pressure. It is dose dependent, respiratory depressant. We'll see the next compound, it is chloroform. CHCl3. This is again important halogenated hydrocarbon prepared from bleaching powder and ethyl alcohol. Properties, it is a colorless volatile liquid having characteristic odor and burning taste. It is non-inflammable and freely miscible with water and ether and ethyl alcohol. It must be protected from air and light because otherwise it forms poisonous phosgene. If you see the uses, it is widely used general anesthetic agent. It is used as a solvent for fats and oils. And then we have thiopentone. Thiopentone is, as you can see the structure, we have the barbiturate and thiopentone. Thio is sulfur, so you have SNA, that is thiopentone. Now the name at the position 5 you have one ethyl group and other one is isobutyl methyl methyl butyl group. Okay, so the nomenclature is, the chemical name of thiopentone is sodium 5-ethyl 5-1-methyl butyl 2-thiobarbiturate. If we see the chemistry, thiopentone is intravenous anesthetic. It is a barbituric acid derivative. This is synthesized by condensing thiourea with ethyl 1-methyl butyl malonate. Properties, it is available as thiopentone sodium. It is yellowish hygroscopic powder having characteristic odor and bitter taste. This is the thiopentone sodium solutions are administered by intravenous route to produce anesthesia. It has a short duration of action. It is also used to control convulsions. And then we have hexatal. The brand name is Gravital. Here with respect to the thiopentone, the difference being it is ONA, whereas it was OS in the thiopentone. Also the substituents at position 5, we have one is allyl, the other one is 1-methyl 2-pentenyl substituent. Okay, so the chemical name of methohexatal is sodium plus minus 5-allyl dash 1 dash methyl 5-1-methyl 2-pentenyl barbiturate. This is all again a derivative of barbituric acid. This is available as methohexatal sodium, and this is a colorless or slightly yellowish crystalline powder. Methohexatal sodium is freely soluble in water. It is used as a general anesthetic and hypnotic. This is administered either by intravenous route or intramuscular route. It is more potent than thiopentone sodium. Thank you, and you can find the notes in the link which I have given in the description.